This is day 16 of Advent of Code 2024 Done and Go, and this challenge is called Reindeer Maze. It's time again for the Reindeer Olympics. This year, the big event is the Reindeer Maze, where the reindeer compete for the lowest score. You and the historians arrive to search for the chief right as the event is about to start. It wouldn't hurt to watch a little, right? The reindeer start on the start tile, marked S, facing east, and need to reach the end tile marked E. They can move forward one tile at a time, increasing the score by 1, but never into a wall. They can also rotate clockwise or counterclockwise 90 degrees at a time, increasing their score by 1,000 points. To figure out the best place to sit, you start by grabbing a map, your puzzle input from a nearby kiosk. So this for example. There are many paths through this maze, but taking any of the best paths would incur a score of only 7,036. This can be achieved by taking a total of 36 steps forward and turning 90 degrees a total of 7 times, like that. Then here's a second example of this maze. In this maze, the best path costs 11,048 points. Following one such path would look like that. Note that the path shown above includes 190 degree turn as the very first move, rotating the reindeer from facing east towards north. Analyze your map carefully. What is the lowest score a reindeer could possibly get? Okay, so let's get started. So my thoughts for this, we have the maze, we look at where we currently are, and we figure out whereabouts can we move. So we move, if there's only one space we can go, we go forward. If there's 2 places, so we have here, we could go forward or 90 degrees to the right. We then kind of duplicate this one and make one of them go forward and one of them go to the right. What we now do is figure out which one has the lowest score. So it's this one. We continue going on, and as there's multiple spaces they can turn to, move to, etc., you create those and you just keep going through, finding the one which has the lowest score and then following the path like that. But if it reaches a dead end or that one now has the high score, then go to the next one and keep doing that, and kind of goes through like that. So we need to first start off with creating the grid. This is make list of runes with a length of lines. So as I said, actually okay, that's a large thing here. So we need to keep record of the state. So let's say type state. So struct. We also need to keep track of whereabouts we are located on the grid, so we'll do type point, and that's also a struct. And this is xy int. We then do position, which is a point, direction, which is an int. The way that we will handle this is we'll use numbers 0, 1, 2, 3 to keep as keys for directions. So if we're east, which let's say that's 1, if you want to do a 90 degree turn, we'll do like -1 for north, or sorry, -1 for north, or +1 for south. So that is how that will work. And we will also have a score here, int, and we might need to keep track of where we've already been, because it's possible that we might go into a place we've already been before, maybe. Yeah, I may as well do that. Previous positions, and that will be map with point and do bool. Okay, why is this error redeclared in this block? Where's point? Oh, we've already got it declared in day 15. Okay, we're gonna go here and rename the day 15 one to point D15. Okay, now we can stick to just point here. No, you were not meant to change. Go back to this. There we go. And we'll also need directions. This will be map int. No, it's not a map, it's a list of points. And we just do, so we'll do north is 0, so 0, -1. Now we need to copy you down, so now we'll go, let's make this east, 0, south, and west. No, east is that, west is that. Okay, we've got directions now. So we need to fill in the grid for I equals 0, I less than length of lines, I plus. And because that's a string, we can do grid I is equal to list of rune, convert the line to that. And we also need to, what's going on here? Okay, we need to do var for that. Var equals, and why are you wrong? Right, comma line, and okay, I just need to do range lines. There we go. And what's wrong with this? Undefined range needs to be singleless. Needs to be single. So we do this, and in the input, we are looking for S and E. So start as S, end as E. Okay, so we need, I will change this to Y, and then we need to do for X car in range line. Oh yeah, I need to start end is a point. Need to do var for that. So if car equal S start is equal to point with XY, then we do this. Else if I need to do E, the same thing. Oh no, well, end. So we've now built the grid. Okay, so we've got this. Now we need to think about how we approach this. So we need to, so we've got our starting one. We'd probably need a list of some sort to store all the current positions that we're doing. So we go through, we start with the lowest number, we keep going to the lowest number, and ooh, actually something I just realized. We don't need to store that here, we do that here, because if we're doing the lowest score first, if that goes to a location, then that is the one that got to that location the quickest. And then if that doesn't make it to the end, then we're looking at another one, and then that goes to that location. That will have a higher score in the end. So we can only go to a location once. I should say the path which gets to the location first, that is the fastest one to get there. So if we ever reach that point again, then we just cancel that. So that is what we'll do. So we'll equal map. Wait, no, make. Actually, this, okay, we need to change this because there's also direction. There could be a crossroads where one is going up and goes to a point, but the one is coming from another direction and then gets to that point, but they're going in a different way. So I need to change that. I'll just do 3 ints. So it'll be X, Y, point. So previous positions. So we will create a queue, which will be list of states. Well, actually, this one will start off with start, like that. Cannot use start variable of type point. Okay, that makes sense. So I need to do so state position direction score. Okay, so we'll create a new state, which is start. Start. It's going east. So 1 and 0. So we've got that. We'll just do a for loop to begin with, without a condition. Something we do need is a function for. We'll do var lowest state equals func, and then what this will do is, I should be able to do that. Let's say we'll do min is equal to -1 for s in range q if min equals -1 or s dot score less than min, oops, where was that, lowest. Actually, I can change this. I can make this a state, although I'd have to define now points. So let's do 0 0 0. So 0 0 0 -1, I think. So is that score? Yes. So if min dot score is that, or if that is less than dot score, min is equal to s. Then we return s. Actually, we're going to return int state because we need to keep track of what index it is as well. And what's wrong here? Missing comma u. Index -1. Index equals I. Then we return is. Oh no, I min. And what's wrong here? Non-declaration statement outside function body. What does that mean? Missing composite literal. Do I need a comma here? Is that what it's trying to say? No. Oh, actually, so missing these for the multiple returns, I think. Declared and not used. Fine. Yep, that's fine. What's wrong with you? Declared and not used. Okay. Wait, what do you mean not used? It's used right here. Ah, I forgot to do that one as well. So we've got this. Now let's do current index and current state is equal to this. We have now got that. So what we need to do is first, if current state dot position is equal to end, then okay, we're doing output like that. We do output equals current state dot score, then break. If that's not the case, we need to look at the three possible directions. So let's do if grid. Actually, we need to do. Let's do left, forward, right is equal to directions current state direction -1, and this would be the same thing, so that and that, but then this one is without the minus and this one is +1. I actually need to do no, I need to change this. We'll do current left is equal to state, and this state would be point. We can do current state dot point position current state dot direction -1. Then we need to do modulus of this, so modulus 4, and then current state dot score. Too many arguments in conversion state. How's there too many arguments? It's 1, 2, 3. Score? What? That's 1, 2, 3. What do you mean too many arguments in conversion to state? Do I need to do this? Okay. Let me try just copying this then. Okay. Curly brace. There we go. So now, same thing but for current right. Direction +1 modulus 4. So I think what we would do, if grid, let's say current left dot position y plus current left direction, but then this needs to be directions left. Okay, I need to do variables for these. Left is this, then we do right as that. Okay, this would be plus left dot. So that's a point, so that should be dot. Why isn't it dot y? Then it would be the same thing but with x. And I just want to see this. No. What does the map look like? Hashes. So if that does not equal hash, current left dot position is equal to point x y, then current left dot score is equal to plus equal 1000. Done the direction already, and then q equals append current left. Now we need to do the exact same thing for right, so I just need to make sure I copy everything correctly in here, which I hopefully have, and then left there. The current right position is this. If it does not equal hash, adds 1000, you do that. And now we do the exact same thing once more, but with current state. And I need to add current that's with the current state. And we use current with this. Oh yeah, I need to what I need to do is include previous positions. So if it's at this end, otherwise, if previous positions current state dot position, what do we do? Okay, something that we could do. So I was trying to need to remove it from the queue, but in this function we could remove min from it. So q is what would this be? We need to do append, and it'll be q from beginning with the length index, and then it'll be q. Q index onwards. Cannot use q index of value of type state. What? Actually, this should be +1 maybe. Oh right, we need to spread the list, because you're starting off. What you're saying is, okay, I have this list, and then I'm going to add these values to this list, but without the spread, it's still a list. Okay, I've got it now. So, okay, so because I've done this, I don't need to return index. The whole point was I was going to use the index later on when I update it. So we don't need index. And why aren't you working? Oh wait, I can do that later, so... well, I already did append the current state to it, so that works. Previous positions, what's wrong with this? Right. This is int 3, current position, dot, do y, then we'll do x, then we will do direction, or not position, direction. Wait, current state dot, why doesn't it give me direction? Do I need to get rid of a comma or something? What's going on? Expected type found, okay, int, direction. There we go. So, we've ran lower state to retrieve the state that we're currently on, but that's removed it from the list. If we get to here and it's already been to a certain location, we then just do continue. Because it's already removed, we've got nothing else that we need to do. That might be all they have to do. No idea. But let's chuck this in. So use the test input to see if this code actually runs. It's taking a long time, so let's see what's going on. Q, how many length of 148.051? That doesn't sound right. 113, 112, 213. Something tells me I forgot to actually move. Oh no, that looks right. I'm moving. Okay, maybe this condition doesn't work. So let's query current state. Position 1, 3, yeah. And you're here. Okay, that's not updating. Did I forget to do it on this one? Okay, let's look at what's in the queue. I feel like maybe direction. So we've got a bunch with a score of 1000. Let's take a look at this. So where are they located? So let's go 213, 112, 213, 112. So nothing is changing. I mean, it adds the first one incorrectly, but... Oh, I think the issue is we're not removing the current one when we progress. Maybe? Okay. We actually do need the index. Wait. Why is... I don't understand. Wait. I did the wrong thing. I put right there instead of current. Wait. Yeah, I completely messed up. Okay. Current, I need to get rid of all these. Was right and current, right. So I've got 4 current for that. Then I also need to change this to 1. Okay, now let's do this. Let's see, where are you current? There you are. You don't seem to be moving. What's in the queue? Okay, I might need to take a proper look at this, because I feel like maybe it's not getting removed from the queue when it should. So when we do current state, the queue should go to empty, and it didn't. So you might need to do +1 here. Didn't mean to run that, but where are we? What are we looking for? We're looking for this. Need to make sure that it gets removed from the queue. Where are you, queue? Okay, now the queue's empty. Good. So let's put the breakpoint here, and let's run it. Queue is now 1. Oh no, it's empty. Why are you empty? Oh no, that seems to be working, maybe. Current left. Okay, so I went to negative and then did that. Okay, what's the left is equal to this if left less than 0, left plus equals 4, else left modulus equals 4, and then we use left here. And why you got an error? We'll do left key, because that's the key used for finding the actual direction. So now let's try run it. 7029. That sounded like so close. How do we get 7029? Okay, let's put this inside of here. Let's go to the end. So current state, whereabouts are you? 13.1. That is there. But how did you get there that less than this? What? Ooh, okay, I just noticed something. We're getting 7029. The correct output is 7036, which is a difference of 7 and the number of times they rotated. So that means I am doing this wrong because I am rotating and going forward. That's why this code does not work. So I need to, you know what, I'll keep this check, but then I'll remove this from the actual output. So we do check to see if it's a wall, but we don't actually move. And then when we get to it, we do move. So keep this and then remove this. So if we run that now, we should get 7036, I think it was. There we go, 7036. We will switch over to the real input, and hopefully this works as expected. Okay, well it seems like it's gone stuck. Yeah, so it's just not doing anything anymore. Maybe I need to... what am I looking for? Where are we doing... we're not adding this in. Okay, so now we do this equals true. So now let's try rerun it. There we go. Now we have an answer, 98416. So let's go back here, submit it. Sweet. That is part 1 done. Now on to part 2. Now that you know what the best paths look like, you can figure out the best spot to sit. Every non-wall tile, S dot or E, is equipped with places to sit along the edges of the tile. While determining which of these tiles would be the best spot to sit depends on a whole bunch of factors. How comfortable the seats are, how far away the bathrooms are, whether there's a pillar blocking your view, etc. The most important factor is whether the tile is on one of the best paths through the maze. If you sit somewhere else, you'd miss all the action. So, you'll need to determine which tiles are part of any best path through the maze, including the S and D tiles. In the first example, there are 45 tiles, marked O, that are part of at least one of the various best paths through the maze. In the second example, there are 64 tiles that are part of at least one of the best paths. Okay, so I think it means there are multiple ways to go from S to E with the exact number of tiles, or let's say so it's let's count how many turns there are. So that's like 1, 2, 3, 4. Oh, actually, so these would all be the same. So let's go 1, 2, 3, 4. No, that would be 1, 2, 3. Okay, so there's 1, 2, 3. So that covers that. Then there's 1, 2, 3. Then there's 1, 2, 3. And I assume they all take the same path distance. So we need to change some things with it. We'll first start off by copying all the code from part 1 into it. But what we will do, we'll add paths in here, which will be, oh actually no, tiles. This will be a list of points. And we'll just initialize list of points like this for all of these from the previous one, so we stop getting errors. Where are you? Same thing here and here. And then here, here, and finally here, here. So we'll switch back to this one, and let's see, where are we? What is the initial one? We're about to start. So we do this, start, I'm trying to find this one. Okay, so, don't know why there's 2 states in there, it's weird. Oh right, okay, that makes sense. Don't need that. But in this one, it's going to be point start inside of the previous. So now every time we add to the queue, current left, and we need to change that so it's not like this, it's current start dot tiles, and we add that to here, and we then do current left dot tiles equals append, and we do current left position. Then we do the same thing here, but now it's current right for all of these, and then we do the same thing here, but it's current state. Whoop, let's put that back. Current state. So we have all these points in it. What we then do up here, let's do min points is equal to -1. Then inside of, we'll chuck this closer down to here, min points is -1. And we can do if min points does not equal -1 and min points is less than current state.score, continue. And we don't, okay, so we need to now do length of queue is equal to greater than 0. So we'll eventually be removing everything from the queue. And min points, best routes, don't know if what I'm meant to call that, list of state, this, best routes equals append current state. And we don't do this anymore, but once this queue ends, we go through, we'll do best tiles is equal to map, and this will be point in the bool, but we need to make that first. Now we go for route in range best routes for tile in route dot tiles best tiles tile dot just tile is equal to true. And I forgot my range there. Then output is equal to length of best tiles. Let's see if that works. Okay, well we got 32, which is wrong. Let's print over here. So what do we have in best routes? We have 1 in there. So with this we can't use previous position. So let's comment that out and see if that fixes it. Oh, that's kind of annoying because that'll take a while to run. Oh, still 32. Did I leave the break in? Yes, I did. Okay. Oh, it's already taken a long time, so this is an issue. Okay, let me go to here. Where's Q? You're here. Okay. It's just gonna be forever increasing. I need a check in here, and we'll do this as well. And we can do, and if it'll let me type, and min points does not equal -1. Because I mean, if we're doing it plus 1000, then it's gonna go. Okay, no. And min points is equal to -1, or no. Okay, we're just gonna remove that from here. We'll add that condition to here. If min points is equal to -1, or min points is greater than current left dot score. So we are going to do that for all of these. So we'll do that, put current right in, then we will do this again and put current state in. So now let's rerun it and hopefully that works. Ah, I forgot to change these variables. So current state, current to right. Now try again. So I've got the first one done. Let's wait, did I do the wrong check? Okay, no, that seems to be right. Well, let's try again. So is the queue still just ever increasing? 32,000, let's continue it. It is still ever increasing. Okay. Okay, let's find something in the queue. What's going on with you? Ah, okay. We are going to change this condition. Already visited equals false for tile in range current state tiles. If current state dot position equals tile. Already visited equals true. Break. Then we do if already visited continue. Maybe that will work. I hope so. Let's try it. Let's get rid of that breakpoint. Wait. Oh, okay, so it returns. Yeah, I should have seen that. We are going to change tiles. Where do we initialize it? Nope, that's the wrong one I'm looking for. State. So here, where do I create it? Wait, okay, where's start? Yeah, so we're not going to do this anymore. And then in here, nope, that doesn't work. Not sure what to do for this. Okay, I do. I know what to do. Keep that. Where am I doing this check? I need to do the direction, and then I'm just going to use this with the. Nope. I need to change it again. Already visited. Undo all that stuff I just did. This goes when we add it. If you're trying to go to a location that is already in yours, then you do not go there. And we add this afterwards. So we then do if not already visited. We put this into it, and it will be current left tiles, current left position, already visited. I'm not liking how this code's looking. It just feels too messy. So I think that's all it needs to be, like that. Then same thing again here, and current state this. Oh, hopefully that works. 0. Okay, we're gonna have to go take a look through what's going on. So where's the queue? Here we've got... Okay, so it just straight up doesn't work. So we have to actually run through it. What condition is it failing on? So go to here. Already visited, false. If left position equals tile. What? It's... okay. I need to include direction. Yep. 3 int. Now every single place that I've used tiles is now broken, which is really cool. Actually, that's 3 int. Okay, so now we need to do this as start. We'll do x start. Wait, what? How was I doing before this? Previous positions. Like I was doing y first. Start y. Start dot x and 1. Ah, this is meant to be int now. So let's copy this, and we will go to these errors. So position, dot direction. And now we need to go through and rechange it. It's a list of 3 ints. Okay. Can I do that? Yes, I can. Good. Current tiles. Then this needs to be 3 int current position dot y, current position dot x, current position direction. And I need to also include the int there. So I need to do the same thing here, but with current to right. Oh, whoops. I'm sure there's going to be so many errors within this, and it's going to be hell to fix. Okay, so best tiles. Now I need to change this to int 3. Okay, there's an error somewhere here. Okay, so we're now at this point. Did I do... Okay, I did that here. That's current left. Let's go through these now. Now I need to make this current to right. And then the same thing down here. With current state. Whew. That took forever, and I bet it's still going to return 0. Okay, that's a breakpoint. Let's run it. Still just infinitely adding to queue. Okay, so I didn't want to keep recording because I was kind of stuck for a long time, and I don't want to spend the rest of my night editing this video, so I forgot the number there. Wait, it is 45, right? I haven't actually checked. I saw the number. I was pretty sure. Yeah, okay, cool. 45. And so I basically reset part 2. So all that extra code I was adding down to here, mostly gone, but we are keeping the tiles. And it took me forever to figure out on this grid, how do I handle when they overlap each other? It took me, I was thinking for ages just how you would record that, and then I realized instead of just so I did add back the keeping track of whether a tile has been visited before, but what I realized is if these diverge like they have and they meet again, they should have the exact same score as each other. So if they get to the end, they'll have the same score, so they'll have the same score here. I've done that instead, so, where is it? So we're storing the location and an int. And when we are... Actually, I probably should test it on this one as well. So I kind of just got excited straight away. But I don't even know if it works. Okay, got 64, good. Okay, yeah, we'll keep it there. Let's just go over the code again, because I did delete quite a bit, so I think this is mostly the same. So, keeping track of minimum score. Min score is for the one that reaches it first, so just making sure you don't bother looking at ones which are over the score. Okay, one thing I changed, instead of keeping a list of the paths or the states, when it reaches the end, we now have a map of the tiles that we're saving. Okay, there's this ugly code here. So we're saving a value in the previous positions. So if it's not equal to 0, but the score within it is less than what your current score is, or in other words, you've gone over it, continue. And then it goes on as normal. Yeah, I've got this. Yeah, so I think I got rid of all that disgusting code I had added to here, because I didn't need any of it. But let's now test it on the real one, and hopefully it works. And that took quite a bit of time to run. Oh, when I say quite a bit, like 20 seconds, which was... So I was getting worried there, but we got 471. I feel like that's low, but maybe not. So let's enter it in, 471. Oh, and that was the answer. So, if you like this video, make sure to like and subscribe.